All right. Hey everyone, I'm David Room. We're back with more work on our retro space combat game. We're doing some functionality we've been working on for a while where we are implementing gravity and celestial bodies, planets, and moons. And there's one last thing kind of left to do here, and that's implement the sun as a celestial body so we can get the proper size of the sun for whatever planet we're at. And I think this should be pretty straightforward. Probably along with this, I'm going to be starting to implement some data structures and constants and functionality for setting up the kind of things that I've been working on where, we have a planet and a moon and we want to kind of lay everything out in a nice way. Um, One other piece that we might be looking at is inclinations of orbits. There's some missing pieces that I don't know exactly how to deal with where um, you know the sort of relative rotation of the inclinations of the orbits of different celestial bodies. I've tried to figure this out in the past. It's not going to be something that I'm going to figure out tonight, but at least if we got the inclinations correct, we would see the right angle of the sun on planets. We wouldn't have to um, be taking guesses at that. That would just work properly. So let's get right into it. I'm going to start up some White Bat audio, and this is going to be Industrial Dark Synthwave Ether. It's been a while since I've listened to this one, so we'll see how it is. I hope everybody had a good week. I had a long week, but a good week, and I'm looking forward to kind of take it easy weekend. And everyone else is in bed, and it's my time to take it easy and write some code. So let's get started. Okay. All right. Yeah, Doug Wise is here. He says weekend chill stream hits different after a long week. Absolutely. Um, it's it's been a week. It's been a week, but something that I've taken a lot of pride in this year is a lot of things going on. Busy times. Just when you have a family and you have kids, lots of little random sicknesses and illnesses and different things going on. But I've managed to accomplish a lot that I'm proud of through that, including some work on this project. So, let's get started. Actually, before I get started with the sun, we're just going to look at a couple things. So last time we ran into what appeared to be a bug with how we were visualizing orbits with different central bodies. I should probably figure out what the exact term is, but I think we fixed that. There's like 4 different cases in the process for converting an orbital state to orbital elements, and handling those now makes that consistent. So it wasn't a bug. It was just a sort of a singularity divergence in that calculation. So let's take a look. Oh, my eyes are bothering me. All right, let's take a look at that. So, and thinking more about this, I don't really think it makes sense necessarily to have this kind of view with showing, like, using our velocity to show an orbit around Uranus, because this could do some weird stuff. Like if we were, say, on the opposite side of this moon where our velocity was pointing this way, that really wouldn't be a meaningful thing to show like what an orbit of Uranus would be. But I still think it's good that we kind of sketch this out, because I would like to be able to see things like, okay, we have you know, I'd like to be able to see the orbit of the moon around around Uranus. So I think it was worth it um, for just getting the UI kind of working. And maybe once we get the sun stuff working properly, we can come back and make the UI do something more sensible. But let's just focus on the sun, because that is really, really, really long overdue. And just for starters, let's make a different scenario and get that set up properly. And then come back to this one. Because I think, for one thing, the sun's going to be really far away. It might be really tiny here. And, yeah. Okay, so, yeah, let's take a look at Mission 1, actually. So, Mission 1, I think I just have... I don't have any orbital velocity here. It's just the station, and I think, yeah, I just have the moon here, but we could swap this moon out for Venus, and do a correct calculation of the sun. So let's do that. Okay, so yep, and I'm just doing moon skybox here, but we'll swap this out for a real skybox. Feels good after a long week of not getting to do nearly enough actual writing of code in my day job to actually sit and type out some code. Okay, actually, we'll just get in the habit of actually naming these things properly. So Venus orbit radius. We need to look this up, and then so this will be the orbit, the radius of our orbit around Venus. And we'll set this up as a radius times 3. And something we can do here, you know, I like to write these things out a couple of times before we start building other abstractions, but this might need something cleaner here. we'll build our real skybox here. This, I think. Let's just try something. So I think, let's see here. The I think, yeah, so the orbital inclination of Venus is like less than 4 degrees. So just for now, let's just set a straight flat sun position. And now, something that we're going to do is probably for the sun and for the celestial body that's like orbiting the sun, you know, that will be stationary, those two things, because we don't want to be always tweaking the position of the sunlight. So we'll want to make sure that the sun position is like what we are expecting once we get there. Yeah, but let's just test this first. And yeah, this is this old stuff. Let's just do these imports properly here too. And start cleaning up after ourselves here properly. There it is. It's really cool how much life you get from adding those planets in. Now, something I think it actually doesn't hurt to just go ahead and add that planet, even if we're not setting up actual orbits. Let's see. I'm curious to see what happens if we get some kind of bad result. I don't think we will. So we'll just say like this. At least we should be able to see our kind of our distance from the sun there. It's interesting that that is... Oh, look at this. The station is falling in towards the planet. That's great. Because we didn't set up the orbital velocity. So let's actually, oh geez. And see the ship is maintaining its position because it has thrusters. That's cool. Yeah, it's just 0.1 G, but that thing's going pretty fast. Okay, let's actually give it. Let's just give ourselves an orbit, actual orbit here, as long as we're doing it. This kind of stuff is just fun. It's something to see this kind of come alive here. Yeah. Okay, so yeah, it's going to be the same thing here. I'm just gotta think if there's a way I can do this in such a way that it I'm not making assumptions about what my position in orbit was. And I think what I have to do is I just have to do a cross product. The unit vector is going to be the cross product of unit z with a unit version of our radial. I think it's called the radial vector. So let's actually just do that quick. Let's see here. R hat equals and let's see what is the station? Station is 2, so let's just grab this guy. Station entities to player. I think player should already be a thing. Let's see here. Player. Oh, I should actually just do this. And station B, right? So R hat is going to be planet. Planet pause normalized and z hat just for now. We'd want to use the normal to the orbital plane here eventually, but for now we can use v hat unit z. So then our v hat is going to be z hat crossed with the radial vector, right? Z hat dot cross R hat, and then the desired, let's see here, Venus. Let's see, I'll just call it the pause orbit is going to be orbit stuff. Oh, and I haven't imported orbits yet. Stop orbital velocity of Venus. Stop mass. Stop phys.mass. Orbit radius. And we will give the station.phys.vpause. Actually, this will just be b hat times this. B hat times this. And we'll give the player that same velocity. Now, we should no longer be falling, and we should have a nice orbit. So this is kind of like going through and rewriting some of the stuff we did for that first mission for this other simpler setup. And it doesn't like this, so like 3D hat. Oh, we just got to convert this back to a vector. Yep, and then we've got to set our reference point to be, if we look at this, okay, something's not quite right here, but there's something else that we've got to do. So, yeah. Game.entRef equals station. Let's see here. Yeah. So there we have our nice orbit. Cool. Okay. Sometime, probably not on stream, I've got to fix the big ol' shadow map reference point to follow the follow the reference point so we don't get this crawl on stuff. And if the other thing we got to do is we got to fix the grid stuff because we've got this crazy grid, but that's okay. Okay, so we've got that set up. Now let's get the right sun position. So time to look a couple things up on Wikipedia. So orbit of Venus. very low eccentricity. For now, we'll just approximate these things as circles. Okay, so now what we can do is we can say, okay, our sun position is actually going to be this. And we'll just normalize this. Now, we can use the sun position to add a new celestial body for our skybox, which is a sun. So let's see here. We're going to look at this, see. Sun. Zooming stars skybox. We set up with, and I'm still using that smiley for the sun. There's got to be just a sphere that I can use. Here. I not just have a sphere somewhere? Sphere egg. Okay, yeah, I should be able to use this one. Let's see here. Let me see how I load the planet description in here. It's model info versus game init, game model info, file name. Yeah, this should work, right? I hope. If it doesn't start with part, we take the add path. This starts with part. So let's see. Let's see if this works. This is kind of good to test. Okay, so this should load up the sun and actually give it the right size and distance. And so we should see maybe 2 suns if this is working, and then we can add some stuff where basically we can disable the sun disk here when we have it be a real celestial body. And I think by default it should be stationary, so that should be okay. Let's just see what happens here. I'm sure something is going to go wrong, but we'll find out. Okay. Yeah, as usual, this went wrong. Let me see if see, I just don't get why this doesn't work. There's something about these load functions that don't play nice with this. UV part game. Let's see here. What format is this? Point as here? Okay. I think it's okay if I think this should work. I'm not going to get hung up on solving this problem again. Well, we can hard code in a special case for the sun if we Wait, where did that come from? Oh, defaults. TDS defaults. Okay, we got through loading it, so that's good. All right. I think I probably didn't set the position on it. On the actual, yeah. Sun.phys.pos equals sun position. Yeah. Now you can see there's something going on there. And if I look at forces, okay. Oh, I didn't add it. I didn't add it to the list of celestial bodies. Position is like 3D, and then we'll change this to vec 3. We might not. I probably need some functionality to just disable gravitational forces too. Wow, something. Not a fan of something here. Jeez. Wow, what is all this? Some position done. What is going on here? What is going on here? Like 3. Let's revert this and convert this to vec. Something weird going on there. Now we should see. Yeah, it's like a very small force from the sun, and I probably want to be able to just disable that because it's, you know, I don't really want to set up velocities for that other stuff, but okay, so but it is there. Now what we want to do is we want to do some special stuff. So we'll kind of do some tweaks for now. In here, we want to grab out the sun. Sun NP. Let's see here. Our smiley sun. Oh my gosh. Oh, smiley egg. Smiley.egg. Sun. Find. There it is. And just for starters, we can hide that guy. And right. Ankit says hello. Yep. Now see, there's our new sun disk. And what we want to do is we want to make that white and take the light off of it. So what we can do just for now, so okay, so once we add these planet skyboxes, now if we skybox np.ls here, we should see that we should see Venus and the sun. So just for now, yeah, planet sun. So just for now, we can do some kind of hard-coded special stuff for the sun. So we can sun np equals skybox np.find planet sun. Oh, that's kind of goofy to call it a planet, but that's just how it is. And then if sun np, let's see, I think it's .empty is what we need to say. Actually, let's check something here. So I always forget. It's like if you use find on something and it doesn't exist, you don't get none, you get like an empty node path or something. Yeah, not found. So like print sun, it's like sun np dot is empty, I think. Yeah, so if it's not empty, so if not sun np that is empty, then we are going to do some special stuff here. So so let's see what we're doing right now. This is kind of like where are we? Sun factor, sun color. Okay, so we want to actually set set the sun to the sun color. P. Set the light to be off. And that should do it. So we should see a nice little bright sun disk now. And what? Yeah. And there's a little bit of glow around it, but what I was thinking we could do at some point is sort of do a sort of like a lens flare kind of effect, where the closer we face towards the sun, the bigger we kind of put like a sort of semi-transparent halo around it that grows. But that makes sense. Like that sun disk is pretty small, and I think that's kind of how it would be, right? So let's see here. Phase of sun disk. Yeah, from the perspective of Venus, the sun's apparent size is about 0.7 degrees. Slightly smaller at Earth, 0.5 degrees. So it is pretty small. Now the fun thing is you know, we don't have to make this realistic. We could add some kind of scale factor. But I definitely think like some kind of big flare would be cool. Would be cool to add. So I've got to think about what the right way to do that is, and I've got to tweak the skybox, because there are stars that are like bigger than the sun in our skybox, because I want to show a variety of sizes of stars. But now let's just check so we can actually test here. Let's say instead of putting this the actual orbit of Venus, we put it at kind of like we've been doing, where we do like the radius of that thing times 3. It should be really big in the sky like a planet, right? So sun.info.radius, actually let's just do times 10. So now we should have a huge sun in the sky. Yeah. Yep. Cool. And because we're taking the sun position and then normalizing it here, it should be proper. And actually what we can even do is we can even do this special case of hiding the zooming skybox, zooming star skybox sun, only if we actually have a actual celestial body sun that we added. Now, what are some other things we can do? I kind of want to exclude the sun, so it's not like I want to be able to put it, well, I don't know. I don't think I really want the sun exerting forces, even though they're really small. So let's set up something where we can just exclude the sun from the simulation, even though it's added. And actually, let's just see something. The sun should show up as a thing that we can show orbit relative to. We might have some kind of... Yeah, it's just, we're just falling towards the sun. Faster and faster. Okay. Yeah, let's set up something where we can just exclude the sun from generating any forces. Because it should be stationary by default, but I mean, let's see, state game. Where is my celestial body class? Forces not accumulated and applied. What should we call this? Like, ignore. So we could say ignore is if true, don't generate gravity. And this should not default to true. It should ignore equals false. So let's just see, does this should still run. We still have forces from the sun. And gravity. So here we're exerting a force on, and here we're exerting a force on body B, or on body A with body B. So we want to say something like if body B dot ignore continue. Right. So now we can just see, nope, that's not working. Oh, I needed to actually set it. So sun.ignore is true. Okay, what's going on now? If body B dot ignore continue, sun ignore should be true. Body B. This is the forces on body A. Body B. Ignore equals false. And this isn't frozen. Is there something else that is generating force from the sun? I don't think so. let me just add a little thing to make sure that this is actually getting, this is where this is coming from. Oh, this is the wrong, we need to do it up here too. That's what I missed. So if body dot ignore up here. And we can rename that to something other than ignore too, but yeah, okay. So we've got the sun, it's an actual celestial body, but it's not generating any gravitational forces. Let's just see if we get anything. Anything when we we just kind of get nonsense here. And that's the fact that those two are different, I think, is just, it's like a degenerate condition, so it's nothing to worry about. Okay, well, this is good, and this is pretty much the main thing that I wanted to get in there. I think let me see. There are a couple other things that I might like to work on. I'm trying to remember what. So we've got the real sun now. Why don't we actually patch this back into Uranus, and then let's mess around with the orbits viewer a little bit more. Oh, I know what I was talking about. I was talking about inclinations of orbits of planets, but I don't really feel like doing that tonight, so we're not gonna. Maybe actually, as long as we're thinking about this, let's solidify a couple of these things here. Oh, I knew, I know what I wanted to do. I wanted to see if there is some symbology that we could add where we show the reference point, because that's kind of important functionality, and we want to be able to double check and easily see what that reference point is if we're switching things around. So actually, let's just, I want to see one other thing here. Yeah. So I was in the, let's see here. Actually, I don't want to get distracted by that. Actually, yeah, we should just call this station orbit. A lot of this is just figuring out the right name for things for the first time. Okay. Let's yeah, let's I want to show that reference point. Let's do that. So I some of the stuff in the HUD I use like the colors from NATO symbology. I'm curious if there's like a reference point or like a symbol that would make sense. I use different things. Like the targeting brackets. I'm wondering if something like a circle would actually be nice. Because I don't think I really have circles. I have triangles, hexagons, the squares. These are like all unit symbols. Installation icons. Topographical. Let me just do a quick Google search. NATO reference. Single vertical tick mark. Yeah, we'll just do a circle. Okay, so targeting UI. Oops, arrows, brackets. Now there should only be one reference point, right? So yeah, we'll just call this, we'll call it ref np. This is a bit overdue. Oh, nice. Jupiter BJY is here. How's it going? It's good to see you. Yeah, so I implemented, I've been working on planets and things, and I've got planets like sizes in the skybox being scaled properly, and I added the sun to that as well, so we can put the sun in a real position and have the size and position of it scale properly. So and what I'm doing now is I'm adding some things, so I have a nice targeting, a specific targeting thing for the reference point, so we can always see our reference point. Yeah, so we'll just call this ref np, and this will be a circle with what, maybe like 9 points. I have no idea what the scale should be for this. Because we're not going to scale this with the bracket NP. This is going to take a lot after bracket, I think. Face direction arrow. Man, I wish I could have gotten that face direction thing to work. Something big. Okay. So these node paths for, so Jupyter BJY asked what these node paths are for. So these are all for the targeting UI. So everything that, like every entity or whatever, It has like a few different things that correspond to it. It has like a blip in your radar. It has a bracket that goes around it, and then it has an arrow that points to it. So these are like the prototypes that are copied, and then there's dictionaries that are stored for everything. But there's going to be only one reference point, so the reference point won't be a prototype. It should just be the there should just be one. And we just have to sort of, I think we're just gonna have to reparent it to the right thing. So basically, if we look at how brackets work, oh yeah, and then there's fires too, which are like the intercepts and things that predict the position of targets. So let's see here. And somewhere in here we should be looping over the brackets. Target bracket. Text. Update arrows. Yeah. So it's going to be basically just like brackets. And I think we can just do the reference point here too, because it's going to be something similar. So, and do we have access to game? We actually don't, so maybe we want a new one. So def update ref camera, is it called ref EMT? And ref. And actually this, we want to just handle hiding this if it's not there. So this is a little bit of an anti-pattern, but in my opinion, but it's kind of fine for what we're doing. So if ref is none, targeting UI dot return yeah, we could add text. We could add text to it as well, right? So that might be a use for this. Actually, we might not need camera. So let's just see here. Otherwise, we'll show it. Show and yeah, okay. Yeah, we're just looking at the camera. Yeah, we do need this. Jupiter BJY says, so this targeting marker isn't attached to entity, but copy follows entity's position. Yeah. There may or may not be a good reason for that. I'm just following how I do it for brackets. So Panda 3D is sometimes kind of awkward in how the parenting relationships work between things. And in this case, I'm just sort of trying to manually do that following. And it's not a lot of code, but it's maybe, like, I don't know, I find it maybe a little bit easier to sort of understand what's going on here looking at something written out like this versus, you know, adding these different, like, transform properties on node paths and stuff. And actually, we can just use this. We can just use this same logic. Not targeted. Yeah, this will actually do exactly what we want. So I believe, yeah, so Jupiter BJY says that makes more sense to me. I used to parent to entity and I kept making the mistake of deleting entity tree as a whole and also delete targeting marker. Yeah, it's sort of silly, but I like to think of the targeting markers as being like in the ship's computer, whereas the scene graph of the entities is like the actual ships. So that's kind of another reason to keep things separate. I'm still sort of learning the best way to write code, but you know, you can do a lot of nice things if you sort of separate parts of the scene graph, or if you add intermediate nodes in the scene graph just for like the purposes of being able to toggle certain parts of the scene graph. So kind of figuring out the right way to do that sometimes is a little tricky, but okay, now what we have to do is we have to make sure that this entref is repaired to the right thing at some point. So let's see, where are our brackets getting added? So if we add an arrow, see, actually, it's not brackets, it's brackets NP is the analogy here. Brackets NP. I think we just got it to You know, okay, so what we could actually do here is see, we could just add ref np to np. We could just add ref np to brackets. So ref np dot be parent to brackets np. I think yeah. So Jupiter BJY says, agreed, we might write more code of boilerplate initially, but it feels like it totally worth it in the longer run to separate things. Yeah, I mean, it's hard to tell what's worth it in the long run, but I think what is nice, yeah, there we go. Look at that. There's our nice little circle. And if I do that, unfortunately that's still there. I think, set known as reference point. Okay, so there's some of the logic is a little bit messed up there, but let's see here. We should see if I target that ship and then set the reference point. Yeah. Oh, okay. We've just got... Oh, I know what I did. I reparented it to the wrong thing, I think. Yeah, brackets, NP. Not quite. Now it's there, so I'm not setting the position quite right. Okay. Oh, I know why. I'm never actually calling update ref. That's why. Okay, so update brackets. I'm calling here. So I need to update ref. Update ref. Camera. Targeting UI. And game dot. Uh-oh, don't have a game here. Or entref. Why don't I just add that here? Ooh, there's a lot of places that gets updated. Yeah, this is... Okay, I think that's actually... Okay, they're just 2 spots. Okay, there we go. And if I get rid of it, it disappears. If I target that ship and say F, there it is. Nice. Okay, so let's just tweak things a little bit. FNP. bracket scale fac times distance. Let's just make this rough scale fac is 0.1. Couple more points to look like a circle. Yep. Look at that. Let me just turn on the mouse quick and see, make sure things are zooming. Like we expect. Let me zoom. I think that's okay. Should probably have these symbols not scale with zoom, but it is kind of a nice way to debug. Gosh, that looks cool. All right, nice. And if we wanted to, we could add some additional stuff on there, like text that shows the distance or the relative velocity or something like that. Cool. I think, let's see here, we've been going an hour and a half. Let me just see if there was something else that I wanted to do specifically. Let me just think here. Oh, I see maybe a problem. That reference point is casting a little shadow, I think. Let's see here. Let me see if I can see that. That might be a little visual glitch we've got to debug. Yeah, you can see Yeah, Jupiter BJY says, oh, this orbital view thing is neat. Yeah, so it just shows, you know, for a given reference, what the orbit looks like. And you can kind of see, like, my orbit compared to the station. There's a little, I need to tweak that to make it look nicer. There's some scale factor stuff that isn't quite worked out there. But once you settle into having the same velocity, which for some reason I'm struggling to do here, then the two orbits kind of match up. What gives? Oh, there we go. That's weird. Something is going wrong with our... Is it just something with the mouse? Something is going wrong with our reference point setting there. Oh, maybe I think I know what happened. I probably turned on drift. Yeah, I think that's what happened. And that would explain why I wasn't able to control stuff properly either. Let me see if I can see that shadow. And I thought... See, like, I have the brackets hidden from shadow. Maybe it's something else that was causing that. There's some weird cases where UI elements cause strange shadows and things like that, but yeah, it was, I had drift turned on, that's what happened. And if I turn that off, it disappears. We don't see that circle anywhere. If I put it back, it comes back. Yeah, I mean, everything is kind of looking good here. I don't know if you saw this, Jupiter BJY, but the planets are faked in the skybox, right? But if you the positions are real, right? So like if you fly away really fast, like that, the planet will get smaller. It might take a lot to do it here, but Now, if we whoops, I stepped the wrong way with the time multiplier. Yeah. It's probably actually easier to see. It's easier to see with a smaller planet, but yeah. So it is not a billboard. It's in the skybox. It's a 3D model that's in the skybox, but it is scaled to correspond to the visible size of the real object, wherever it is. And because everything now has double precision coordinates, we can put things, you know, very, very far away with accuracy, and see that stuff happen. So if we go back to mission 4, actually let's just see, because mission 4 should still work with the original sun. Like, the sun is way too big, but like we might be able to see Umbriel get smaller, faster, because Umbriel's a lot smaller. Yeah, like here you can actually see it getting a little bit smaller here. Let me just turn drift on and turn up the time multiplier to a point. Yeah, so like there you can see it. You can see it getting smaller. And it's not just the scale, it's the position too. So if you are like moving great distances, you should see the angle of that thing in the skybox relative to you change. Like you should technically actually be able to fly around a moon. I should actually test that. That would be a good test. Yeah, and you can see these charts kind of show what's going on. Yes, this skybox is the same one that I have the zoom agnostic star. So all of that stuff works together now. It's pretty cool. If I turn the mouse on, conceivably, you should be able to go fast enough and figure out how to take a trajectory that would put that station on the opposite side of the planet of the moon from you. I believe that should be possible. And you get these weird trajectories, degenerate orbits, depending on your velocity. The distances are still pretty big. Let me see, can I... And this planet is small enough and we're close enough that it's hard to, I mean, like, I don't know what exactly a trajectory that, because I think there's a limit to how fast you can fly around a planet. I'm not sure. Let's see, we're on a very different trajectory from the station already, where we're a lot closer to the planet. I could actually look here and watch my do things that take me in closer. Combat's still happening out here. It's kind of funny. And I think that the period of this orbit is still long enough. The collision avoidance stuff is, I think, enemy stuff that's going on. The period of this orbit is such that it is still long enough that it takes a while for us to move. And I hit the wrong direction on the time scaling, so it's frozen now. But yeah. All right, well, I think that we made some pretty good progress tonight. We got the sun working in a more realistic way. We got our reference point in the targeting system. That's pretty useful to be able to see, you know, what our reference point is. It's kind of funny. You could actually, I think, if you wanted to, like, you could chase an enemy by. You could chase an enemy by setting it as your reference point or match speed. Let's just go back to the combat zone here. See, they didn't start with the velocity of orbiting the planet, so that's why they're behind. But what I should do is I should set up some more of the scenarios now that we've got the pieces. Set up some more of the scenarios to actually take place in orbit. I need to make a nice Earth planet so I can do Earth and the Moon and some other planets in the system and set up the scenarios around those, so we have some better tests. We're still kind of hacking that stuff in here, but and then I do want to show show things properly. So like this view isn't super useful, but you know, something where it is showing the moon that we're orbiting as well, and you know, somehow explains that here, and maybe even draws the orbits. Yeah, draws the orbit of that moon rather than us. Because I could try all I want, and I'm probably not gonna like radically change. I don't know, maybe I'm wrong. Probably not gonna radically change my orbit relative to Uranus. You know, like if I do something like fly inward as fast as I can, and then stop. I don't know if that's going to be like visibly that different of a trajectory. So Jupiter BJY says, regarding orbits, I remember you having maximum velocity limit. Is it fixed or changes depend on reference point? Yeah, so that's sort of another change, is that velocity limit now is relative to a reference point. So like right now that the station is a reference point. So this velocity is relative to the reference point of the station. And one of the interesting things, right, is that, you know, because there's forces acting on us, you know, I might not necessarily be perfectly following these different trajectories or whatever, but if I can set that as a reference point, then my thrusters or whatever can keep me in position relative to that reference point, even if our you know, even if my velocity and position doesn't quite match up, right? So like you can see right here, you can actually see that my orbit is really not quite the same. But it will you can see like occasionally the drive flashes, and if I turn 90 degrees, the thruster is flashing. So the drives and thrusters are just tweaking a little bit to try to keep me at zero velocity relative to that position. And if I turn it off, right? If I turn off the reference point, now let's see, did I turn drift on? Okay. So if I set the reference point to none, now my reference point is basically just the origin of the coordinate system. So now you can see that I have a very high velocity relative to that reference point. Or I should say, for a while, but then my drives killed it, and now my drives will be basically fighting the pull of gravity of the different celestial bodies. So so you can see basically Oh, and actually, yeah, and actually, this isn't really kind of doing what you'd think either, because Umbriel is actually orbiting Uranus here. The reference point is like changing relative to this moon. So we're actually seeing right now. We're seeing this is cool actually. So we're actually seeing Umbriel move past us now in its orbit around Uranus. So we are holding position. We've slowed down to 0, and we're seeing Umbriel move in its orbit, and it might, I don't know, we'll see if how close it gets, but we're seeing Umbriel move in its orbit around Uranus relative to us. So that's cool. That's kind of a neat way to see this stuff working. Yeah, yeah. Jupiter BJY says having that implemented is quite neat. So we basically have inertia dampeners for any reference point. Yes, exactly. And going through this answered a really important question that I had, which is, I didn't think that, because my accelerations are so high, I didn't think it would really matter, like the fact, like say we're in orbit, right? We have that reference point that is a point that is orbiting, somewhere in our vicinity. Because our accelerations and from our drives and thrusters are so high, I figured that it more or less didn't matter that we were orbiting, and that is basically the case, right? Because at any point, right? Like maybe if we go back to mission 1, because we're not orbiting a body that's also orbiting something. There's just one orbit here, right? So if I put a little bit of room here, and then because we're not right here, we're not modeling Venus orbiting the sun. Venus is just sitting there in space, right? What is happening here, right, is we have Venus exerting a force on us. We're slowing down from our orbital velocity to 0, and then our thrusters and drives will just try to keep us stationary at this spot in space. So for the orbital velocity for this orbit, it doesn't take long at all to slow down. So now we're at a spot, and you can just see, at like some multiple of the radius of the planet, it just is like a negligible fraction of the capability of our thrusters and drives to just stay in that spot. Now, like if we move a lot closer, right? Let's see here, station, orbit radius. Like if we move a lot closer, like if we move in really close, it's so cool that just works. So let's bring up our orbit view again. So see, our velocity is a lot higher, so it's going to take a bit longer to bring us down to nothing. And both our thrusters and drives are firing just because I'm not exactly aligned with the optimal direction for doing this. But okay, so now we're here, right? We're still just like, what, a total of about 0.7 Gs to just stay in this spot, which makes sense, right? Like, Venus is roughly the size, I mean, it's a little smaller than Earth. We're a little farther away from the surface, so as long as we can just sustain thrust of around 1 G, we can just stay stationary in that spot. Oh, and this is cool. We can actually see like we're okay, so this is cool. We're actually, it's a small enough orbit that you can actually see the station moving. And if we turn up the time multiplier, see, like for these smaller orbits, they get pretty fast. Yeah, station is orbiting while we are basically staying stationary. And you can see it's the radial vector moving here. So if we, I mean, it's out of range to see, but like if we watch this long enough, it should actually move behind the horizon of the planet, right? So I don't know, like it might take a long time to get that far, but we could actually see. The simulation does get pretty slow. Yeah, that would take, I think that would take quite a while. Yeah, okay, so Jupiter BJY says, there should be more games with these sort of mechanics. Maybe only space nerds like us would enjoy, but it's so cool to watch. Yeah, and you know, I feel like, I mean, this is just me being biased, but I feel like there's sort of a neat spot between like hard sci-fi, because I wouldn't really call my sci-fi setting hard sci-fi, because it's like all the ships have crazy levels of acceleration and stuff, and kind of like these magic drives and power sources and stuff, but the actual orbital mechanics and physics and stuff still matters. It's kind of neat to have both, and you know, just having some realistic physics while you do this stuff is sort of interesting. Just for kicks and giggles, as long as a few people are watching, let's ding with this scenario a little bit, and let's give that other ship some velocity as well, and then we'll have a little fight around the station and see how it goes. We'll just turn off the mouse for just a second. So so now he should be sitting here at the station. And the... Nope. There he goes. Alright. We've got a set. That's strange. Did he have some starting velocity? That's really strange that he disappeared like that. So Jupiter BJY says, by the way, how would that inertia dampening thing affect controllability? Would it only make craft less responsive for anti-gravity axis direction? Yeah, I mean, you should be able to feel it a little bit, but I think like I was saying, you don't notice it a ton because it's just like, even for like a very low orbit, it's just like a small fraction of what the ships can actually generate in terms of thrust. You know, maybe it would be more, it would like feel like something more if you couldn't just generate that level of thrust constantly. You know, like if you had to do it in bursts, maybe if you were fighting it, if you were fighting that, it would you'd be able to feel it a little bit more. Okay, what is going on with this guy? That I wonder. I wonder if something... Now see, I feel like setting this should be affecting... The reference point should actually affect everybody, I think. Which is maybe, you know, not something that we necessarily want to do, but... Let me take a look at that. Yeah. Yeah, this actually affects everybody's flight assist. So, yeah, why isn't... This is an interesting bug. Oh, there's the problem. So that's actually something that we want to make sure we want to actually have a separate entity reference for each, because like if I turn this off now, yeah, we're both sort of like drifting away different ways. But yeah, let's just turn him on and have a little dogfight. This probably won't last super long. Actually, it's not really a dogfight, but yeah, there's definitely some weird. Oh, maybe it was him that was casting the shadow. There's some weird shadow stuff going on. Yeah, see, like you're saying, Jupiter BJY, I think you could probably feel the pull of that gravity in how your controls respond if you had less thrust available, and like depending on the situation, but oh geez. Why isn't he firing on me? Did I disable his... Oh yeah, I just got rid of all of his turrets. Okay, now this is going to be scary. Not sure what happened there. He bounced off something. The collision detection needs some work. Oh yeah, he hit something and got a very extreme velocity vector. Yeah, there's some collision stuff that needs some work. Let's see if we try that again, if that still happens. I'll try to lure him down this way. Yeah. 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 Okay, I know what's going on. There's some bugs that I have to work out with the impulses relating to the relative velocity, and that's why the stuff is acting weird. It would not act weird if we weren't actually orbiting. So like, let me just do this. Let's say so we'll still add these celestial bodies, but we'll say if false else, and we'll just say we'll say Venus.ignore string, so it won't generate any gravity. That is nice because that makes this a lot easier to turn on and off. Yeah, so here we shouldn't see that weird thing. There's some heuristics that I added for the collision detection that I think, yeah, there's something, I'm using absolute velocity somewhere where I shouldn't be. And overall too, the ships need to be a lot more careful about not crashing into things, especially the big ships. Yeah. It's kind of funny to see him bounce around like that. But okay, so Jupiter BJY says I had inertia dampening mode for thrusted orbiting, circling entity fixed distance, and I had barely any thrust margin, so controlling wasn't really responsive for my case. Yeah, so what's happening with the teleporting is it's bad heuristics for collision resolution. So I have some functionality that is handling what happens when you collide with things, and it just does not work that well yet. I was hoping to find a solution that worked with these modes of Panda 3D where I could just make a collision mesh and I wouldn't have to like make custom collision objects for things, but it just something like it doesn't seem to work well. And I'm not sure why. Like other times I've tried this and I don't know if I broke something with the 3D vectors or what, but like I felt like I had this working at one point where I was getting these pretty reliable collisions and stuff, but now it's just like sometimes I'm bouncing off, sometimes I'm not, and then you get these super high weird impulses sometimes, like we saw with him, where he's just like spinning off out of control. So definitely something that I need to investigate further and set up some better things to debug with. Yeah, I think the problem is there is somewhere that I have some heuristics that are using some measurements that don't make sense anymore after this refactor. See, like there, that's kind of doing what I want it to do. But it's too easy to slip into and through things. And like, yeah, like high velocity, it should be a lot harder actually to slip in, but it's not. So something is going wrong. And he's just way off in La La Land, so yeah, definitely needs some more work, the collision stuff, but all right. Well, I think we had a good evening here. There's always more to work on, but we made some good progress with the sun stuff and reference points. Thanks to everybody who tuned in to watch. It's fun hanging out. I hope you had a good Friday, good week. Hope you have a good weekend, and good luck with your projects. Thanks as always, Jupiter, BJY, and Doug for coming to hang out, and yeah. Have a good night.